And then we can welcome our next speaker, who is Rob Laidlow. So it's my pleasure to introduce Rob. He is a composer and a researcher in artificial intelligence in association with the BBC Philharmonic Orchestra. He works with Professor David Deruer in collaboration with the Royal Northern College of Music and Oxford. And today we'll talk about Collaborator tool catalyst, the roles of artificial intelligence in the compositional process. So please, Rob, the stage is yours.
Thank you for that introduction. Nice to see you. Yes, so today I'd like to give a sort of overview of a few projects I've done with classical music ensembles that use machine learning in different ways during the compositional process. And hopefully through these case studies, I'll show that depending on your definition of the terms in the title, tool, catalyst, collaborator, and the way that you approach using this kind of technology, that we can have lots of different approaches that result in hopefully interesting music, which I'll play a little bit of as well. So let me share my screen. Okay. Here we go. Yeah. So as mentioned, I'm doing my PhD at the moment at the Royal Northern College of Music with PRISM, the Centre for Practice and Research in Science and Music. But I've worked with quite a few collaborators whom I will introduce as we go along. So I'd just like to start off by talking a little bit about which kind of algorithms I'm using today in my work and why. So when it comes to music algorithms, there are some sophisticated symbolic algorithms which produce sheet music or sort of MIDI kind of music that learn from symbolic data. And there are audio generative algorithms as well, which learn from raw audio and produce new samples on a sample by sample basis. So yes, so I use symbolic and audio generative models, and also I'm going to talk a little bit about text-based models as well, which exist in the same domain as symbolic music models. So machine learning I've used to generate text for pieces of music in various ways. Okay, so the first of the case studies I'd like to talk about today is a piece called Alter that I wrote in 2019 with quite a large team of interdisciplinary collaborators. It was a Barbican Centre commission for the Britten Sinfonia. Oh, there's all the information all at once. There you go. And it was for an event focused on Ada Lovelace. So I'm sure everyone knows who Ada Lovelace is, but if you don't, she was a 19th century pioneer, mathematician, musician that lots of modern day computer scientists are very interested in what she had to say about her ideas about what computers might be in the future. So this was an event responding to her. And the piece responded to her work in lots of different ways. One of them, you can see on the right-hand side here, was I worked with an engineer to 3D print a new instrument based on the analytical and different engines that Ada Lovelace was writing about, these proto-computers that Charles Babbage invented or proposed. But more to the topic today, we wanted to use lots of different AI algorithms to respond to Lovelace's work in different ways. So I used symbolic generative algorithms for both some of the music in the piece and also to generate the text that the singer sang. And I did that in collaboration with David Deruer, who's here as part of his Turing fellowship that we developed these text generating algorithms together. I also used some audio generative algorithms, and I used WaveNet for this. And I used a little technique that I called hidden layers as well, which is when I generate new music using symbolic or audio generative algorithms, and then put it into the compositional process at quite an early stage and then develop it myself. So lots of the piece that you'll hear, if you hear it, has music that is profoundly influenced by the way that machine learning creates music and the way that it learns from music, but that isn't directly generated by machine learning. So we have both there. We have verbatim quoting of it and development of machine learning based ideas. I'll play a bit of this piece in a moment, but for now, let me show you the graph of the big graph. So I'm going to go through this in a little bit more detail just to show how this piece was written. So at the end here, the final product is this piece here, alto, for mezzo, soprano, and ensemble. And alto on stage, what you see is a combination of musicians playing notated musical material and an electronic soundscape that's played through the speakers on stage in this case. So let's go through the notated musical material just to show some of the creative process. We have up here, contributing to the musical material, the score, is OpenAI's MuseNet algorithm, which I'm very lucky to work with Christine from OpenAI quite extensively. And we fine-tuned MuseNet, which is a symbolic music generative algorithm that can imitate specific composers' styles. We fine-tuned it on my own music using a data set of my music. And what this did is it will generate music that you know how machine learning works. It deems to be indistinguishable or as indistinguishable as possible from my own music, which is a very interesting place to start because it's fascinating to analyze what it is the algorithm picks up in my work and what it doesn't, and what ideas I find very compelling and what I don't. And some of this material went in verbatim, as you can see. We also had another use of MuseNet down here, where I instructed it not to write music in my style for the ensemble, but in the style of Robert Schumann, the classical composer, whose dates lie very closely with Ada Lovelace's own dates of her life. And this provided a little bit of AI-generated, but sort of contemporary or pastiche music that was blended into the texture as well, which I then developed along with ideas from the percussion instrument I talked about earlier to create more of the musical score. Another element that went into the score was, of course, the singer and the text that she sang. So I'll just go through this process here, which is quite iterative and a really interesting way of approaching generating text, actually. So together with Dave, we created two text-based recurrent neural networks with different data sets. So the first data set, we took all of Lovelace's letters and used that as the training material, and only that. And found the generated material, put some of it straight into the sung text, so some of that from the first model, the singer sings directly, and other parts of it we used as a prompt or as a sort of starting off point for the next RNN model, which we trained on a wider set of 19th century texts, more Jane Austen, Charles Darwin, or whatever it was that we used. Dave will have more information on that, I'm sure. And with the results of that second RNN, we did the same thing. So some of that went straight into the sung text, and more of it was used as a prompt for a final model, which we used a sort of fine-tuned version of OpenAI GPT-2 for, which obviously has a very large data set. If you know GPT-2, this is before GPT-3 was released. It has a data set taken from the entire sort of internet. And what we found with this approach was that despite the fact that our first two algorithms, I would say, weren't particularly sophisticated, what was really interesting in the way that they linked together was how the first model might pick up on certain ways that Lovelace spoke or certain 19th century isms that were then kind of expanded and developed and really picked up on, we felt anyway, by the second model, which magnified lots of little words or phrases that the first model created. And again, this being fed into GPT-2 provided some really interesting results, because GPT-2, if you know it, because it's got such a large data set and because it's so big, it can often create quite bland sounding material, things that maybe sound a little bit like a news article and that kind of thing. But using this material that had come from our very carefully selected data set earlier in the pipeline actually pushed this big algorithm in a very strange direction. It really sort of almost had a bit of a breakdown, actually. It kind of like forgot how to do grammar and how to string certain ideas together in various ways. It was very, very artistically interesting to try and find a way to push such a big model in a new direction using smaller models. And then I'll just say a quick word about this electronic soundscape down here as well. So what we did here was similar to how the text was developed. We developed an electronic sort of machine learning based voice throughout the piece. So at the beginning, we used WaveNet samples that were trained on people speaking, and we just isolated strange words that don't really exist because they sound like they should exist, but WaveNet doesn't understand the syntactic content of audio files. It will only understand raw sort of spectrographic information. And we went from that through to creating a sort of pre-recorded electronic line that was sung by an electronic singer that's on stage as well. I don't want to get into too much detail about that, only to say that we mirrored the process of the symbolic text generative ideas with audio that you can hear during the piece as well. So that's a very quick run through of Alter. Let me just play you a little bit of that. I'll play you a section from about 2/3 of the way through where we hear the singer singing in duet with herself. And you will hear some AI generated text, and you will hear some AI generated lines sung over the electronics part. I hope, if the internet works. Can we hear that?
No, we cannot hear.
Probably forgot to share the sound. Pause that out. I hope you could hear that. If you can't, then and you'd like to, my website is at the end. I hope it's audible. Okay, so in this piece, Alter, I would describe the use of AI or machine learning very much in the sort of tool category of what I spoke about, what the title of this presentation is. We're using it in lots of different ways, and it's being really embedded into the compositional process. And thinking about the piece in terms of a sort of chart like this, I find quite helpful, especially when working with lots of other collaborators, such as Dave here, but also engineers and historians, and computer scientists, all in this piece. We all sort of contribute together. And I really see the algorithm's outputs as an important part of that process in a way that we don't actually always have much terminology to describe in classical music. I think that's a talk for another time, but I think there's a real issue with being able to talk about pieces that are created by more than one person. Okay, so let me talk a little bit about this piece, 3 Entistatios, which I wrote in 2019 for the BBC film. This is 12 players. And what I wanted to do with this piece was explore the process of training a machine learning model audibly across the piece as a whole, which is in 3 movements. And to also use those models I was trying to explore as part of the compositional material. And so for this, I wanted to stop the training of certain machine learning models. And actually for this, I used MuseNet again before it was kind of ready, or before it had reached a sort of peak level of efficiency. I think the efficiency or accuracy is a really interesting thing to think about as an artist working with this kind of material, because sometimes the kind of raw, sort of not ready, all over the place material that a machine learning model might produce at the start of a training process can be some of the most interesting material. So in this sense, I wanted the materials to speak about themselves. At the part of the piece where I'm trying to explore the start of the training process, we'll hear music from the start of the training process and so on. This word Entistatios is also a machine learning generated word from something trained on the dictionary, which it defined as a short piece of music or metal, which is just brilliant, I think, because obviously you can have a piece of metal or a piece of music, but like the word piece is very different in both of those contexts. So these Entistatios are 3 short pieces, and they have 3 or more short bits of metal in them as well that the percussionists play at various points. And in this piece, I wanted to explore some solutions to problems thrown up by using machine learning in the compositional process. And there are 2 particular problems I wanted to look at to find a solution for. If you were trying to create music just by machine learning alone and weren't trying to compose around it or use it as material in your work, you might find that often machine learning music generations get stuck in ruts. They begin to repeat themselves endlessly. This is actually true for text generation as well. You'll also find that it's very difficult to maintain a sense of memory or long-term coherence over a piece of music generated by machine learning. Transformers are quite good at this now, but even so, even the best transformers can only produce pieces of music that are a couple of minutes long at most, before by the time you get to the 4th minute, it really doesn't bear much resemblance at all to the 1st minute. It's kind of forgotten or moved on from the musical material that the piece began with. So I wanted to come up with some solutions that might not only mitigate these issues, but also kind of turn them into a feature rather than a bug, as you will say. So I have 3 solutions for working out some of these problems. The first is what I call interlocking. And I use this in the second movement of this second Entistatio, which I'll play you in a moment. And what this means is that I write a prompt, a sort of first few bars, and then I provide it to, in this case, MuseNet, my symbolic generative model, and it generates the next few bars. And then I stop it before it can kind of forget or wander off or get bored or whatever it is it does after a minute or so. And then I take that as my prompt and continue to write from there. And in this way, we kind of build up a section-based piece of music where we're swapping material. And in this case in particular, the machine learning model is attempting to imitate my style, as I mentioned earlier. And as the composer, I'm trying to create something that feels fluid. And so therefore, I'm sort of imitating the machine learning style to keep the music consistent over a long period. And it's really, really interesting for a couple of reasons. But the main one for me is that it's actually very difficult as a composer of notated music to surprise yourself during the compositional process. Normally, everything is worked out in advance, and you at least know roughly what your music is going to sound like. But by kind of introducing these interlocking elements where you write a bit, but then you really don't have any control over what's coming next, apart from overall hyperparameters that you might set in advance, which even then are quite vague. It's very interesting that you can have a piece of music that is being sort of created on the fly, and you're not quite sure where it's going to go, but you're trying to lead it in certain directions, or you can try and lead it in certain directions. But there'll be things in there which surprise you. I really like that. The second mitigation method I used is what I called collaging, which is that instead of trying to sort of link all these little ideas that the machine learning comes up together somehow, I'm really trying to double down on the fact that it can produce so many ideas so quickly, and they all do sound very different. And what I found in this piece, but also in the last piece, Alter, is that if you produce, say, 20 little snippets, maybe like 5 seconds long each or something, and then overlay them all on top of each other, not only can you get something that sounds quite meaningful, but also your ear can actually begin to pick out certain elements of the machine learning's fingerprints, sort of the things it tends to do again and again over many generations. The kind of things you might not notice if you just heard one generation. You wouldn't be sure, because there's so much information there, you wouldn't know what of that music that it has generated is something that it tends to do. But I found that if you collage lots of generations together all at once, you can start to hear the kind of thing that it does again and again. And in this case, for example, repetition, we can overlay sort of 6 ideas, all of which have little repeats in them somewhere. And by overlaying them all at once, we get this audible texture that feels quite static, because everywhere there are these little repetitions everywhere. But also it feels quite in motion, because all the musical material, as I mentioned earlier, is quite distinct from one another because of the problems with memory. So those are 2 solutions I developed for our writing through Entistatios. I'll just play a little bit of the interlocking, and as a hint, I made him play a cowbell every time it changes between my parts and Newsnet's parts. So you might be able to hear that. Yeah, okay. Again, if you'd like to hear more, you can. Just a little note on the trumpet saxophone thing there. Really interesting about symbolic generative models is that because because of the way that it tokenizes music, sometimes it just forgets which instrument it's writing for, and it just introduces a new instrument, which is just brilliant. So like sometimes you'll ask it to generate a piece for a piano and it'll start doing it, and then suddenly this like drum kit will come in and just start playing it. So I wanted to capture a little bit of that, of this just melody sort of pinging between instruments. Okay, and very quickly, I'll just talk a little bit, about the last case study, which is this piece I'm writing for full orchestra called Silicon, and this is the first movement, Silicon Mind. I was really interested in writing it for a small orchestra, what we call a double wind orchestra, the kind of orchestra that Beethoven wrote for, rather than the kind of orchestra you might see today filling up the concert hall. I was interested in this for 2 reasons. Well, first of all, because that was the commission, because it was a pandemic thing and they couldn't fit 80 people in the hall. But also because writing music for a Beethoven-sized orchestra immediately makes you think about what else is going to be in the program. Is it going to be programmed alongside a Beethoven piece, for example? And how does this new music fit in with that historical context? And I think that this idea of future and past is quite important in thinking about new classical music, but also very important in how machine learning models are researched and created in a research context as well. We have this idea of what I've called imitation, which is that a lot of machine learning models for music are based on how successfully they can imitate composers, such as you just heard in my piece. And I think that's a really interesting approach, because from a compositional point of view, it's not always that interesting to be able to imitate Beethoven, for example. And yet, imitating Beethoven, or particularly Bach, seems to be the way that lots of these models are benchmarked to show how successful they are. And in a way, that's quite similar to how classical music is oriented, particularly on the orchestral front. We have lots of old music being performed again and again and again, maybe not imitatively, but certainly we hear, lots of Beethoven's Ninth Symphony, for example, many, many times. There's this idea that the past legitimizes the future somehow, that we can use the past to use the past as a yardstick. And this is what I wanted to investigate with this piece, Silicon, which I can't play you because it hasn't been played yet. But I wanted to push this idea of imitation as far as possible. What would happen if I took an algorithm and got it to imitate Beethoven, but kept pushing it in the strangest direction possible? Whenever it came up with something strange, just kept pushing it that way. Where would we end up? What would that kind of music sound like? Very strange is the answer to that question. And it was a really interesting procedure writing this piece, because all of a sudden we get this idea that, well, actually, can a machine really imitate, in this case, Beethoven? Is that really possible? Or are we just stopping it at the level of imitation that we think sounds like Beethoven? And if we just keep pushing these models further and further, what does it hear in this sheet music? Or what does it see? Or what pattern does it recognize in this music that we don't think sounds like it's imitating Beethoven, but the model does? It's an interesting question that I enjoyed beginning to track down an answer for. The other thing I wanted to do here, which is inspired by a model I saw on YouTube, actually, a music model that was used a convolutional neural network and used images to create music rather than sound files, was creating a classical music that could make sense to an imagined artificial mind of the future. I won't get into this too much, but if computers read music as images, such as waveforms, which they do, then there's no reason that the music needs to go left to right or start to end. You could think of it more as a visual artwork that you just see it all at once. And it's only us that hears music in time. So this piece as well, I wanted to explore different ways that time could run, sort of forwards, backwards, up, down, all sorts of things like that. Yeah. Okay, and yeah, that's pretty much it. So that was about 25 minutes. I'll just go through some other work that that I've done that you might be interested in. One thing I didn't mention here was something else I did with Dave, which was a bark or bot test, where the audience has to hold up signs based on when they think it's bark or AI imitating bark, which we've performed a number of times. It's been really successful, actually. It's really good for getting people to think about what creativity is and whether a machine can be created in the same way bark is. So I've got two more movements of Silicon that explore different questions about the orchestral context of AI in classical music. I've got a few space-specific vocal works, which I'm really interested in, which is using the text generative algorithms that Dave and I began work on in Alter. I've since developed them quite a lot, and I'm really interested in training these algorithms on very specific data sets. Like I've got one of just Manchester-based poets, which I want to put on a concert in Manchester, and see what it finds about all these writings of Manchester-based poets, for example. And I've done a fair bit of folk music work as well. I think folk music and AI is particularly interesting because so much of folk music is not to do with the notes. It's to do with the context and the tradition that it comes from. And I question whether AI can really learn that. Yeah. So I won't go into authenticity. That's much too big. Thank you for listening, and I would welcome any questions. Yeah, thanks.
Thank you very much, Rob. It's super talk, actually. Nice music and nice video, nice talk.